Welcome to qnawire.
All right, so we have a voltaic cell that uses the following reaction. Tl3 plus 2Cr2 plus goes to Tl plus 2Cr3 plus. And has a measured standard cell potential. So measured cell potential, that's E cell naught of positive 1.19 volts. In part A, we are asked to write the two half-cell reactions. So our first reaction, I'm going to take Tl3 plus, and that's aqueous, and it is going to Tl1 plus aqueous. And so in order to balance that, we have 2 electrons over here. And since we're gaining electrons, this is our reduction half reaction. The other reaction will be with the chromium 2 plus going to chromium 3 plus, both of which are aqueous solutions. And in order to balance that charge, we're going to put 1 electron over on this side. And because we're losing electrons, that is our oxidation half reaction. In part B, we're asked, what is the standard reduction potential? By using try that again. In part B, by using data from Appendix E, determine E cell or the E standard for potential for a reduction for the reduction of Tl3 plus to Tl plus. So what we're trying to find is the reduction potential for our reduction reaction. So the overall equation we want to look at here is that E cell standard is equal to the E reduction of the reduction reaction standard minus the E of the oxidation reaction under standard conditions. So we know E cell, they gave that to us up here, and we're trying to find this, and we can find the oxidation. We can find this one in the appendix. So our equation for E reduction is going to be that it is equal to E cell plus the oxidation, right? So I'm just adding this over to the other side, the oxidation. So that's going to be equal to 1.19 volts plus the oxidation, which according to your table is going to be negative 0.41 volts. And therefore you get that the E reduction is equal to 0.78 volts. In part C, we are asked to sketch the voltaic cell, label the anode and cathode, and indicate the direction of electron flow. So I'm going to come over here for our part C. So in our voltaic cell, we have 1/2 cell that has some electrode in it, some inert metal. We don't have anything specific that it's telling us it has to be, but we're going to say this is the anode. And then we have another 1/2 cell over here, and that would be our cathode in there. And again, it doesn't say anything specific, but it's going to be our cathode. We don't have a specific metal that it needs to be. In here is going to be my chromium ions that are, and I will also be gaining Cr3 plus as this reaction occurs. And over here I have my tellurium 3 plus ions. And I have a salt bridge connecting the two. And then I have my wire that connects with some voltmeter and a switch and all that. We might have our voltmeter here, and there's probably going to be some sort of switch here. And the electron flow will always electrons will always flow from the anode to the cathode. So that's my electron flow direction right there. All right, so that should be all of that they asked for in that problem.